Hello there and welcome to the Lower 6 Further Maths A-Level Pure Core 1 past paper for June 2011. In June 2011 it was actually called Further Pure 1, FP1. So what I've done is I've taken most of those questions from that module and added in some extra to make up the whole of the Pure Core 1 module. So let's get started. Question 1 is a new question to Pure Core 1 and it corresponds to the Polynomials chapter, it looks like. F of z is equal to z cubed plus pz squared plus qz minus 12. P and q are the real constants, given that alpha and 4 over alpha and alpha plus 4 over alpha plus 1 are the roots of the equation f of z equals 0. Solve completely, f of z equals 0. So, what we're looking to do here is remember some of those rules that link together the coefficients of the equation and the roots of the equation. Now it looks like the only one it's worthwhile using for the moment is the one at the end. Now I remember for cubics that if I multiply together all of my roots, alpha, beta and gamma, I get minus d over a. Now what do these four letters refer to? The alpha, beta and gamma refer to the roots of the polynomial. D over a represent the coefficients. A in the front of z's cubed, b's here, c's here, and d will be at the end. So, let's substitute in these values and solve an equation. Alpha will be the first root. Our second root is 4 over alpha. And our third root is this big long one at the end. Alpha plus 4 over alpha plus 1 equals minus d over a. D is minus 12, so the double negative there will make it a 12 over a. A is 1, so we'll just have a 12 here. Now looking to simplify this a little bit, we've got alpha times a 4 over alpha, so those two alphas there will cancel out nicely, and if I divide through by 4, I get 3 on the other side. So what I'm left with now is alpha plus 4 over alpha plus 1 equals 3. Now what I can do here to turn this nasty equation into a quadratic equation is just times through everything by alpha. So alpha squared plus 4 plus alpha equals 3 alpha. Now what I need to do with quadratics is get everything on one side, so alpha squared minus 2 alpha plus 4 equals 0. Now looking at this quadratic to do with alphas, I can't see any way of factorising it with two brackets, so I'm going to have to either use the completing the square method or the equation. For this I think I'll use the completing the square method. Alpha minus 1 squared minus 1 plus the 4 equals 0. So alpha minus 1 squared will equal minus 3. And then if I square root both sides, I'll have alpha minus 1 equals... Now I don't square root minus 3. What I do is I square root the 3 and separate it with the square root of minus 1, but we all know the square root of minus 1 is I. So we have alpha equals, I forgot the plus or minus in there, 1 plus or minus square root of 3 I. So in fact that's two of our roots really, because we've got a positive version and a negative version. So we could say here that alpha was 1 plus root 3i and beta here was 1 minus root 3i. Now what I can do here is get the third root, gamma, by going back to my original equation up here, multiplying all three roots together to get minus d over a. So alpha was 1 plus root 3i, beta was 1 minus root 3i, Gamma we still don't know, and we had a 12 at the end of that equation. So let's expand these brackets. We'll get a 1 times 1 is 1. We'll get 3i and a minus 3i, which will cancel out. And then we get minus 3i squared. All of that will be times by gamma, and that will equal 12. I squared was minus 1, remember, so minus 3 times minus 1 makes a positive 3 in total, so that gives me 4 gamma equals 12, so gamma equals 3. So here are my three roots: 1 plus the square root of 3i, 1 minus the square root of 3i, and 3. So that's part A solved, 5 marks for that one. Hence find the value of P and Q. So what they're looking for us to do in part B is to use those other two formulas that link the coefficients together with the roots. Now I remember the easy one is the first one. For P, it's going to be sigma alpha. Now what that represents is adding together all of your roots equals minus B over A. So adding together all of these roots, 1 plus root 3i, add 1 minus root 3i, add 3 equals minus b over a, so it would be minus p over 1, so just minus p. So I'm going to get here 3i will cancel out with a minus 3i, 1, 2, 3, 4, 5. So p is going to equal minus 5. Moving on to the next part for Q. This one's a bit more fiddly. Sigma alpha beta is equal to C over A. Now this refers to you have to multiply two of the roots together, and that will equal C over A. So let's start to do this. We have 1 plus root 3i times 1 minus root 3i. So that's alpha and beta added together. Then we'll do alpha and gamma. So 1 plus root 3i times by 3. And we'll have beta gamma as well. 1 minus root 3i times by gamma, which is 3. And this is going to equal C over A. C is Q, A is 1, so just equal Q. Now, let's simplify what we can here. I've done this calculation before above. That was 1 minus 3i squared. That got me 4. This part here is going to give me 3 plus 3 root I, but I can see at the back here that's going to cancel out with minus 3 root 3i, so I'm not going to write that down. I can see the cancellation there already, and so I've got plus 3, and I've also have a plus 3 here. That will equal Q, so Q will equal 610. So P is minus 5, Q is 10, 3 marks for that bit, 8 marks in total.